let's talk about our other trigonometric functions when it comes to things like phase shifts and changes in the period and all that other kind of good stuff. And we're going to start with a cotangent function in order to illustrate some of the points that we'll need to know in order to make this work. So I refer back to my basic cotangent function all the time as a nice reference. And if you recall, we have the basic function y equals cotangent of x as the kind of function that had a natural period of pi, that had a vertical asymptote at x equals 0 and x equals pi. So I'm just going to sketch it out right here so I just have this visual image in my mind. Had a vertical asymptote at 0, a vertical asymptote at pi, passed through the x-axis at halfway through the cycle. At my quarter points, it would have passed through positive 1 and negative 1 respectively right here as I go left to right. And if I drew this cotangent function right here, it would come down along these points and down along our vertical asymptote. Okay, and since there's no vertical reflection, right, we're not multiplying our cotangent function by a negative right here, we can use this as a reference for us. So how should we do that? Well, of course, we get the value a is equal to 3/2. So normally, where at my quarter points I would be at positive 1 and negative 1 right here. Now I'll be at 3/2, 1.5, above and below the x-axis. So I will go ahead and I'll find that right here. I'll mark these off in halves. So this is 1, this is 2. So 3/2 is right here in between. And here's negative 1, here's negative 2, and so on along my y-axis. And I always label these axes completely. I don't want to lose points on my test. All right, so what else do I know? Well, the period of the function is going to be found by taking pi divided by b, and in this case, the b value is 3. So our period is pi over 3. Now, normally that would mean that our asymptotes would start at 0 and the next point would be at pi over 3. But here's where this becomes useful, this piece of information. Within one cycle, x normally goes from 0 to pi to get our first pair of asymptotes for y equals cotangent of x. But I'll tell you what I do to find my vertical asymptotes right here. I'm going to take this entire argument of 3x minus pi over 4, and I'm going to put it between the natural asymptotes for cotangent, which are at 0 and pi. And I'm going to solve that inequality. So, to solve this inequality, that means I would have to add pi over 4 to both sides of my inequality. So instead of 0, I'll have pi over 4 on the left. I will still have 3x in the center. And I'll have pi plus pi over 4 on the right. I might have to work that out, but that's 5 pi over 4 when I do. Now I'll have to isolate x completely, and I'm going to do that by multiplying each of these terms by 1/3. So every term on the left, every term on the right, I want to isolate x. So that means my asymptotes are going to be 1/3 times pi over 4, that's at pi over 12. And 1/3 times 5 pi over 4, that's 5 pi over 12. So one basic cycle will go on the interval from pi over 12 to 5 pi over 12. So I'll pick out pi over 12 here along my x-axis to go out to 1, 2, 3, 4, 5 pi over 12 here. And actually, you know, that's going to make this graph really look kind of close together. I don't know. I'll stick with it. Here we go. Let me extend this out a little bit here. Let me go every other marking period. So here's our first key point in between. Here's our next. Here's our next. And our asymptote at the end will be 5 pi over 12 if we have one cycle of this function. So let me move this over right here. Vertical asymptote, vertical asymptote. I'm kind of noticing that my markings are a little bit off right here. I'm just going to move those over. Okay, so it looks a little bit more even now. Of course, these other points right over here are kind of in the way, but darn thing. Okay, doesn't want to play. It's all right. Doesn't matter. So now that I'm looking at these points right here, okay, I'm going to ask myself, well, how am I going to get this basic graph going? Well, okay, I have to get these key points in between. So if my period is pi over 3, just like with a sine or cosine function or any others that I've been dealing with, each of my key points are 1/4 of the period apart. So I'm going to take 1/4 times pi over 3 to get pi over 12. So that's how far apart each of my key points are. So if I start at pi over 12, make my little table here, for x at pi over 12, my starting point for my cotangent function, I get an asymptote. So adding pi over 12, an increment of pi over 12, gives me 2 pi over 12. I'll put this in unreduced form here. 2 pi over 12 is my next key point. My next key point will be 3 pi over 12. That will reduce. My next key point will be 4 pi over 12. That will reduce. And then my next key point will be 5 pi over 12. And that one won't reduce. And that was the end of my one cycle in this graph. So putting my reduced values right here, I've got pi over 6 as my next key point. Three pi over 12 reduces to pi over 4, so that's my next key point after that. 4 pi over 12 reduces to pi over 3, so that's my next key point. And then my last key point is 5 pi over 12, and that's where I get another asymptote. So now we ask ourselves, well, what happens at each of these key points? Well, at a quarter way through our period, we are at 1 above on our cotangent graph, but we're multiplying by a equals 3/2, so we're going to be at 3/2 at this point. At pi over 4, we're at halfway through the period. In our natural cotangent function, we're passing through 0. There's no vertical shift right here, so we're going to put this at 0. And at our 3/4 the way through in the cotangent graph, we're at -1, but we're multiplying by a equals 3/2, so we're going to have -3/2 here. So when I'm graphing this function, here are my major points. Pi over 6, I'm at 3/2. Pi over 4, I'm at 0. Pi over 3, I'm at -3/2, and my graph follows along these vertical asymptotes right here through these three key points in the graph and then back down along our vertical asymptote. And so here is an image of our basic cotangent function y equals 3/2 cotangent of 3x minus pi over 4. Okay, more to come.